Hi, I'm Patrick Oguaju, and in this session, I'll be walking through um, real production lessons from designing cost-efficient, high-scale systems with Azure Cosmos DB. This talks about problem many teams face after adoption. Azure Cosmos DB gives you scale and flexibility very quickly, but if your design choices are not deliberate, then costs may likely rise much faster than expected. What I want to show today is that cost problem in Azure Cosmos DB is really just a traffic problem. Um, it's always almost a design problem. Before I get into the technical content, a quick note on where this comes from. I'm a software engineer working across .NET and Azure ecosystem. I spend a lot of time in the intersection of microservices, um, event-driven architecture, cloud native data, and AI systems. The numbers on this slide, the millions of monthly reads, thousands of documents, and a cost reduction. These are from a real retail production system. This has been shipped and measured. We reduced Azure Cosmos DB cost by over 60%. The problem wasn't scale, it was design. The issue was not that the system had grown too large. The issue was that was the way we were partitioning, indexing, querying, storing data, uh, made the workload much more expensive than it needed to be. So today I'll be showing the bad design, the fixes applied, the patterns you could fit back into your own system. Let me describe what this looks like in practice before we get into the architecture. But we have costs growing several times faster than user traffic over a period of months. We have RU spikes appearing with no clear cause, unexplained bursts that exhaust provisioned throughput at random intervals, um, queries that look simple in code, like a slug lookup, page fetch, we're hitting 30 to 80 arrays because they are effectively scanning the whole Azure Cosmos container. The team isn't watching array at all. It was treated as infrastructure noise, not a signal. The last point is very dangerous because um, by the time anyone notices, the habits are already baked into the code base. So let's look at why this happened structurally. Let's use this as an example of a badly set up Azure Cosmos system in production. We have high traffic landing pages, API sends broad queries into Azure Cosmos DB, but every request is a cross partition query, sometimes effectively a full Azure Cosmos container scan. We're mixing hot and cold data, indexing everything by default, and using a partition key that doesn't match access pattern. Each of these may seem manageable in isolation, but if you put them together, they make every request expensive. The costs are not coming from a single bug you can fix in an afternoon. They compound across every layer of the stack. Um, the first fix we had was partitioning. Partitioning isn't just about spreading data evenly. That's just a side effect, not the goal. The real question is, how does your application actually read and write this data under load? You choose a partition key that aligns with your traffic boundary and your most common read path. In our case, that was the site ID. Every meaningful query already scoped to a single site. Um, making that the partition key eliminated cross partition fanouts entirely. It gave us predictable consistent performance at scale, and is the reason we could switch to point read at all. Notice on the right, this is what the Data Explorer um, looks like once the partition key is right. Every document belongs to an evenly distributed logical partition, no hotspots. Once partitioning is aligned, the next hidden cost is indexing. Default indexing is convenient, but it's not free. If you index everything, you're paying RE on every write and every update. Even when large parts of the documents are never used in a query, our document had a metadata block like that contains hero, banner, URL, and the featured product ID array that's we queried in application, but never in Cosmos. We're indexing everything literally. So we moved from default indexing to selective indexing. This kept about 5 fields at the end of it. The site ID is log, category is featured, and last updated timestamp. So everything else, including the entire metadata subtree, were excluded. The impact was immediate. We now have write area drop approximately by 35% because every offset that was previously touching indexing for over 30 fields and never queried, you're no longer there. So that was a lot of silent waste. The next fix is SDK optimization. Even with better partitioning and indexing, application code can still burn RE unnecessarily. That's where SDK optimization comes in. The biggest example you see in this slide is the difference between a query and a point read. The query here, the select statement, costs about 2.94 RE, while the point read, which for the same document, costs about 1.05 RE. That's like a 64% reduction on a single most frequent operation in our system. The point read is only possible because we had the right partition key and because we constructed stable document IDs. That is a compound benefit of mixing things, fixing things in the right order. We also eliminated unnecessary query fanouts and introduced batching patterns where appropriate. These are small code changes, but in aggregate, across millions of reads, they make much difference. The last major fix is to stop treating all data as equally hot. Not all our data were in the hot operational path forever. For instance, we have still campaign pages, expired product listings, old search snapshots. These were accumulating, consuming storage and being scanned on every cross-partition query that ran against the Cosmos Azure Cosmos container. TTL is the simplest lever. You set the default to, let's say, equivalent of 30 days, and Azure Cosmos DB deletes that document server side at 0 RE cost. The one edge case to handle is evergreen documents like global field or core navigation, which must be set explicitly to -1 so that it never gets deleted. The second pattern is code tearing through chain feed. Historical data that you need to keep but never queried can be moved to blob storage using a simple Azure function app on the chain feed. Blob costs roughly 1 cent per gigabyte per month, while the equivalent Azure Cosmos DB storage cost about 25 cents. So that's like 25 times storage cost difference for data that is just sitting idle. The combined impact, will have storage RE reduced by 28%, and the archive cost dropped to less than 5% of what equivalent Azure Cosmos story would have cost. Now, this is the same system, but designed differently. The API uses point reads and targeted single partition queries. The partition key matches traffic patterns. We index only 5 fields. We now have lean documents with metadata excluded from the index. TTL enabled so that stale documents expired automatically, and a chain feed pipeline which moves code data to blob storage. Same workload, much lower cost. We now have lower RU per request, P95 read latency under 15 milliseconds, and cost that scales in a predictable manner with actual usage rather than design depth. Observability is what turns optimization from guesswork into engineering. We use 3 layers. The first, Azure Monitor Insights for normalized RU consumption charts. This is where you correlate spark spikes to specific time windows and operation patterns. Diagnostic logs with data plane request category enabled and routed to log analytics. This is where the your KQL query on this slide becomes your first line of investigation, like your top 10 expensive queries ordered by request charge. And then finally, request charge logging at the SDK level, logging the charge of every operation in the application layer so that you can catch expensive patterns before they reach production. The 3 signals to watch out for include normalized RE consumption. When it's above 80%, it means that you're approaching your provision limits. And any read operation costing more than 10 RE, that's almost certainly indicates a cross-partition query that should be a point read. And if a single physical partition is consuming 3 or more times the average, then your partition key design has a hotspot. This has made the conversation much more concrete. Instead of saying Azure feels expensive, we could say this is the exact query pattern on this exact access path that is responsible for this cost behavior. That's when optimization becomes repeatable. And this leads to the principle that changed how I think about Azure Cosmos DB. RE is not just a metric, it's a feedback. If a simple read is expensive, the design is telling you something. Every time we saw a high RE cost, it points us to a structural problem, a wrong partition key, an unnecessary index, a query that could have been a point read. So you should treat RE consumption as a design review, not an infrastructure problem. Trade-offs are where nuance matters. First, switching to a point read requires constructing stable deterministic document IDs at right time. That could add complexity to the right path. It's what it's since we had a 64% reduction in RU, but it's not free, certainly. The second is TTL. TTL works well, but evergreen documents need explicit handling. When you miss one TTL, which is supposed to set at -1, they end up losing that document completely. So this means I will have to add a defensive document class attribute to enforce it in the code. And the third, we evaluated multi-region rights. Our traffic is over 80% UK based. So adding a second right region would have doubled our provisioned throughput cost for less than 5% latency improvement. So we don't do that, single region, single digits millisecond latency is fine for our SLA. The goal is not to minimize RE at all costs. The goal is to spend RE intentionally. Complexity has a cost too. To make this practical, I've reduced the lessons into 5 principles. These are the 5 pillars I'll leave with. Partition for access. Design how you query, not how you store. Index only what you query. Pay for hot data only. TTL deletes stale data at 0 RU cost to you. Choose point rate, where possible. Measure everything. You cannot improve what you cannot see. Azure Monitor, diagnostic log, SDK request charge, login together gives you complete picture. If you apply these 5 consistently, you would avoid most of the expensive Azure Cosmos DB mistakes we made in production. Azure Cosmos DB doesn't charge you for data. It charges for bad design. The 60% reduction we achieved wasn't as a result of throwing more infrastructure at the problem or renegotiating a contract. It came from understanding how Azure Cosmos DB actually works and aligning our design to it. The pattern is not a secret. They're just not always applied deliberately from the start. Thank you for listening.